Welcome, everyone. Thank you very much for joining us. I'm Vasya, and we have Saurabh as well here with us. So, we are from the Azure SQL Edge team, and today we are going to talk about how Azure SQL Edge provides the flexibility and capabilities to develop smart, renewable energy solutions that leverage machine learning and real time analytics to drive continuous optimization and efficiency. Over to you, Saurabh.
Thank you, Sia. Good morning, good afternoon, good evening, everyone. My name is Saurav Agarwal. I work as a program manager with the SQL Server engineering team at Microsoft. In the session today, we'll talk about Azure SQL Edge and how Azure SQL Edge can be used to build smarter IoT solutions with specific references to the energy sector. Before we talk about Azure SQL Edge, let's take a quick look at the shifting landscape in the energy sector. This change we are experiencing in the energy sector is threefold. The energy sources are changing not only in the way they are produced, that is in a more sustainable, cleaner way, but the sources itself are moving towards renewable energies. Currently, 20% of the planet's energy production comes from green renewable sources, and it's expected to grow to 50% by 2035. If you look at the traditional oil and gas and or power and utility companies, the line between these two sectors or these two companies is blurring. For example, if you look at Shell, Equinor, or Repsol, they have divisions dedicated to renewable energy productions. The second change we are experiencing is in the decentralization, where the usage of distributed energy resources are becoming more mainstream. This increase in the usage of distributed energy resources is expected to be one of the most disruptive trends to the traditional energy industry in the foreseeable future. According to a Navigent report, in the next 10 years, distributed energy resources are expected to grow 9 times faster than net new central station generation, including renewables, across Europe. And then lastly, the third thing we are seeing is in terms of electrification, where if you look at today's where electricity, I mean, if you look at the today's electricity consumption, about 19% of the planet's energy consumption is electricity based, and this is expected to grow to about 30 odd percent in the next 20 to 25 years. This 50% increase in usage of electricity is expected to pose significant challenges to the existing infrastructure or setup which energy companies have. So, what are the energy companies doing? Uh, as you know, most of these energy companies are adapting to these uh, changing landscapes, and they are using IoT to adapt to this changing landscape. If you look at energy sector, the usage of IoT or the implementation of IoT solutions is in many different aspects. If you look at power generation, for example, IoT is being used to increase operational efficiency by optimizing power generation. It's also being used to reduce downtime through automation. For example, if you look at wind turbines or if you look at companies which are building wind turbines, they are utilizing sensors to determine the wake adaptation required for the turbine to optimize power generation. Similarly, IoT solutions are being used to improve transmission and distribution by improving grid performance and reliability. IoT solutions are also used to increase employee and personal safety and to reduce outages. Again, for example, if you look at energy companies or utility companies, they are using sensors and IoT indicators to monitor and predict environmental wear and tear within the grid and take actions to rectify the situation even before an outage can happen. Finally, if you look at the implementation of IoT or the usage of IoT across the customer experience from acquisition all the way to billing, you would notice that IoT is being used to automate the process or the operations across this entire customer journey, right from acquisition to billing. Additionally, what various governments and energy companies are doing is they are incentivizing customers to use more energy efficient equipments. So, for example, in various countries, the usage of energy efficient bulbs and lights is incentivized by the energy companies. But this usage of IoT poses significant or new challenges which traditional energy sectors are not used to. And what are these challenges? So the main challenges are twofold. First is in terms of network and infrastructure. The There are still several pockets in the world where network connectivity is not available. And if it's available, the bandwidth is either too low or the cost is extremely high. 5G promises to solve some of these bandwidth related challenges, but cost and availability would still continue to pose significant challenges in the near future. For example, if you consider a shipping container traveling across the Pacific, though this example is not necessarily related to the energy sector, but uh, it proves the point around availability of network for IoT solutions. If you if you look at the path across the stretch of the Pacific Ocean, there are several areas across the stretch where there is no network connectivity, or if there is network connectivity, the only options are through an expensive satellite connection. The second is in terms of data. The the increase in usage of IoT and IoT devices in the energy sector has led to an explosion in the volume of data generated. Most of this generated data needs to be processed in real time. Essentially, this data needs to be processed, analyzed, and acted upon at the origin itself rather than being processed at a secondary or a tertiary system. As the volume of data increases, transmitting all of this data to a data center or to a cloud target becomes cost prohibitive. And in some cases impractical. Additionally, the growing volume of data and IoT endpoints increases the complexity around storage and security of the data. Right? The challenges related to network and data have made edge computing more prevalent than before. Data needs to be processed on the edge at its origin before it's aggregated, filtered, and shipped to a cloud or a data center target for long-term retention, or it could be used for AI or ML model training or for running some other complex reporting workloads. So the companies or the energy companies are adapting to these new challenges which are introduced through the usage of IoT or IoT solutions. And Azure SQL Edge is one step in that direction or towards solving some of these problems. So Azure SQL Edge, which went into public preview as part of the build announcements, is an optimized data processing engine for IoT. It is built using the same SQL engine which powers SQL Server on premises and SQL services in Azure. It provides the same industry leading security and performance. It also provides the same familiar developer experience, including the same tooling experience, which you already know and trust. Azure SQL Edge is the most versatile data engine for IoT and edge deployments in the sense that it retains most of the performance and almost all security capabilities of SQL Server, including data encryption, classification, and access control. In addition, Azure SQL Edge introduces some key new capabilities to the SQL engine. Chief among those are the fact that Azure SQL Edge is a fully containerized solution which is compatible with most Docker container engines and Kubernetes implementations. It can not only run on Intel or AMD devices, but also includes support for ARM64 platform. SQL Edge includes native support for data streaming to and from different multiple inputs and output targets. This data streaming capability is provided through the same engine which powers Azure Stream Analytics in Azure. Time series processing is another new capability which is being added to SQL Edge. Time series capabilities are of in two different formats. One is through the or in two different aspects essentially. One is through the capabilities provided by the streaming engine itself. The other is through the introduction of new T-SQL functions and syntaxes for querying time series data. And then SQL Edge also adds capabilities for ML inferencing on the edge. Essentially, SQL Edge provides the capability in such a way that you can train your models in Azure or somewhere else and bring those models to SQL Edge for inferencing on the edge. And finally, the data movement capabilities in Azure SQL Edge provides or enables Azure SQL Edge to seamlessly integrate with the rich ecosystem of data services in Azure or Microsoft data services on premises, providing customers a uniform experience across edge and cloud. Now, let's see Azure SQL Edge in action. In the example which I have today, we have SQL Edge, or we will use SQL Edge, or more specifically, the ML capabilities of SQL Edge to determine the wake adaptation required for a wind turbine to optimize the power generation. Let me switch back to my browser window, which has a dashboard representing my wind farm with hundreds of turbines or wind turbines on the farm. Each the central unit of each of these turbines has an instance of Azure SQL Edge running on it. Each turbine is fitted with multiple different sensors to measure things like wind speed, wind direction, oil temperature, so on and so forth. Additionally, data from each of these sensors is streamed to SQL Edge database for processing and inferencing. And finally, data from each of these SQL instances is in turn aggregated, filtered, and uploaded to a cloud target. In this case, the cloud target is Azure Blob Storage. This is essentially for long-term retention and for ML model training. As you can see on the dashboard, an issue was observed with unit 34 or turbine 34. Let's take a closer look at the issue which is being reported. So if you look at the dashboard, you would notice that the expected power generation from this turbine is falling, and it's expected to go significantly lower than what you would expect from the turbine. The same page also shows me that there are no net new mechanical failures or mechanical issues on the turbine. The vibrations, the oil temperatures is pretty much the same. There's no fire, there is no malfunctioning, or there's no part failure detected on the turbine. You also see a graph for security alerts, even though no events are visible to the current user. This is because we are making use of Azure SQL Server or Azure SQL Edge's row-level security capability, where events are hidden from a normal operator and are only visible to the admin for the farm or for the entire dashboard. Let's take a look at some of the environmental factors and see if we can determine what is the issue happening on the turbine. So if you look at the environmental factors on the left-hand side of the dashboard, you would notice the wind speed and the direction of the wind across the farm is pretty stable. It does not change over the period of time. But if you look at that same data for the turbine, that is the wind speed at the turbine and the wind direction at the turbine, that's significantly changing in the last 5 odd minutes. You would notice that the deviation in the wind experienced by the turbine is very high, right? And that's probably what is causing the fall in the expected power generation. So this is just the dashboard, right? Let's actually look at the data from the database and see what is happening. Right. So what I have here is a very simple Python notebook which connects to my turbine 34 and populates some data frames. And what I'm doing is I'll plot a graph of the standard deviation in the wind speed at the turbine vis-a-vis the standard deviation at the wind speed at the farm. And if you look at this graph, you would notice that the same thing what you noticed on the dashboard. Essentially, the standard deviation of the wind speed is pretty high or pretty significant at the turbine than what it is at the farm, right? And if I were to plot the average wind speed at the turbine vis-a-vis the wind speed at the farm level, you would notice that there is a huge change, or there is a considerable change in the wind speed which the turbine is experiencing versus what the farm is experiencing, right? So let's try and correct this problem. So to correct this problem, what we'll do is we'll go ahead and train an Azure ML model. So let me revert back to my Azure ML Studio, where I have a notebook which can be used to train a ML model to determine at what angle the blades of the turbine needs to be rotated to fix this problem, right? Uh, in the cell over here, all I'm doing is I am setting up the experiment or the workspace for my ML experiment. And in the next step is where we are pulling data from your from our Azure Blob storage. Remember, as I was saying earlier, data from each of these SQL Edge instances is being written to blob storage for long-term retention and model training. This is essentially what we are reading from those blob storage or the data stored on the blob storage. Once this data is loaded, I'll create a subset of this data set to understand or visualize how my data, which is on the blob storage, looks like, and whether or not we have enough data points to go ahead and train the model effectively. So we have about 8,000 odd records, which I'm using for the model training. And let me go ahead and quickly uh, plot a graph of the the prediction output, essentially, which is whether my turbine blades need to be altered or not, vis-a-vis the turbine speed standard deviation, the wind direction, and the wind speed at the farm, or the standard deviation of the wind speed at the farm. What you would notice is that the wind speed or the standard deviation in the wind speed at the turbine, if it's very high, you typically get more values of alter blades equals to true. Essentially, at higher standard deviation, there is a need to alter the blade angles to adjust to the conditions. Right. Similarly, for if the direction of the wind is somewhere in between 40 to 50 odd degrees, the number of occurrences of alter blades equals to true is way higher than what it is at other angles. Right. So let me go ahead and create an ML experiment to train the model and run that model as part of my SQL Edge um, engine. So I have created the ML experiment, and in this step here, in this particular step, I am running this model. It takes about 5 odd minutes to run the model and or to run the experiment and to train the model. So in the interest of time, what I'm going to do is I'm going to use a model which I trained about 40 minutes ago before the start of this session. So if you look at this model was trained at 3:41 a.m. on 5:21. So let me go ahead and create a SAS key or SAS URL for this model, which is what I'm going to use as part of my SQL Edge deployment. I will copy this SAS URL and I will take this SAS URL and deploy it as part of my SQL Edge deployment. Let me go ahead and save this. And now let's revert back to the turbine. Once the model has been uh, inserted into the SQL database and the model has been used to infer, you would notice that the alerts which were being observed at the turbine is now stating that it's been resolved. And if I were to go and refresh the data from the turbine, you would notice that this data at the turbine level has normalized. You would see that the value which was earlier very erratic in the sense that the standard deviation was too high has now normalized and it's more or less stable now, right? So this is an example of how you would use Azure ML to train a model in the cloud, but the same model can then be deployed on SQL Edge to derive inferencing and actions at the edge itself. Let me revert back to my slide deck and talk about the next steps. So Azure SQL Edge went into public preview on Tuesday at start of Microsoft Build 2020. If you are more interested in learning about the capabilities of Azure SQL Edge, please refer to the link at aka.ms/SQL Edge. If you are interested in learning about the customer case stories with SQL Edge, there are 2 case stories already published on the customer case sites with Fugro and Zeiss, and more case studies are expected to be published in the near future. If you are interested in learning about the Microsoft industry solutions, refer to the industry solutions at microsoft.com/utilities. Sia, I think we are ready for questions now, if there are any.
Awesome. Yeah, we do have a lot of questions. It's been a pretty engaging audience. The first question, there's a lot of excitement about Azure SQL Edge Preview, and folks want to know how to get hands on this particular product. How do they access it, and what are the different versions available for public
Th-
preview?
that's a very good question. So Azure SQL Edge is today available as a deployable module through IoT Edge. So essentially, you can go to the Azure Marketplace, search for Azure SQL Edge, and then deploy that module through Azure IoT Edge. There are two versions or two editions of Azure SQL Edge available today. One is the developer SKU, and the other one is what we call as the premium SKU. Both of these editions are available free of cost while the product is in preview.
Perfect. The next question is around the fact that SQL Edge, as of now, we have been talking about it in the scenario in the context of IoT, but can it be used for non-IoT scenarios?
Now, SQL Edge is designed and optimized for IoT scenarios in mind. While it can be used for other scenarios, we wouldn't recommend that because most of the capabilities are uh, geared towards IoT solutions and IoT deployments.
Got it. And the third question is around if Azure SQL Edge, if like the question is if they embed Azure SQL Edge in their application, can they distribute it as a part of the overall solution?
So uh, we are still working out the policies around distribution of Azure SQL Edge as a part of, as embeddable part of a solution. But the overall idea is yes, you should be able to embed SQL Edge as part of your IoT solution. We do not have the details on how or what that would cost or
Mhm,
what that would the acquisition process would be today, but we
mhm.
expect to have those details available around the time of general availability of Azure SQL Edge.
Got it. Our next question is regarding performance, and the audience want to know if there's any benchmark results at this point of time for Azure SQL Edge.
We do have internal benchmark results, but unfortunately we do not have anything publicly available yet.
Got it. And you mentioned that one of the key features was data movement or native data movement in Azure. Does it mean it's only Azure SQL database, or do we support other Azure services as well?
No, we are looking at data movement from to almost all Azure data services. To begin with, we are looking at data movement to SQL databases, to Azure SQL DW, to blob storage, to Azure Data Lake Storage, and Cosmos DB. But in the future, we'll also look at increasing that to other services in Azure.
Got it. And what services can be used in PaaS, as in platform as a service, to pull data from Azure SQL Edge?
So as I was saying earlier, right, Azure SQL Edge today, while I mean today it's primarily blob storage and SQL databases, but we are working to introduce support for data movement to services like Cosmos DB, to Azure SQL DW, to Azure Data Lake Storage. So those services can be used to or can be integrated with Azure SQL Edge to pull data from SQL Edge and store on those services.
Okay, and this is more about if SQL Edge is going to span across, in terms of availability, span across AWS and Google Cloud in the future.
SQL
Just
Edge
curious.
So SQL Edge is designed for IoT solutions which run on the extreme edge of your network, right? So by definition, those uh, deployments are outside of a public cloud or of a data center even. So the idea of running, I mean, while theoretically you can run SQL Edge on any platform, it doesn't make sense from a usage point of view as to why you would run SQL Edge on GCP or AWS.
Got it. And this question is more specific to the demo that you just showed us. So was SQL Edge model applied as the twin model prior to adjusting the turbine parameters?
No, so the SQL Edge was actually, or the model was actually applied as a twin property of a additional module, which writes the model into the SQL database. This is just from a demo perspective, but if you look at the announcements across Build, we announced support for Azure Machine Learning extension to Azure Data Studio. You could also use that extension to write the model or to deploy the model to SQL Edge. In this case, this was just another way of deploying that model to SQL Edge.
Got it. And then we have a question around Stream Insight, which was a part of SQL Server, and the user wants to know what happened to that when it came to Azure SQL Edge.
So the the streaming capabilities of Azure SQL Edge are not built on Stream Insights. Essentially, they are built on the engine which powers Azure Stream Analytics. Uh, if you look at the history, uh, there are some components of, or there could be some components of Stream Insights in within the overall code base for Stream Analytics, but mostly it's the new code base which uh, powers Azure Stream Analytics.
Got it. And then we have um, a question as to when this demo will be available on GitHub.
So it is not currently available. We are working to make this available within the next couple of weeks, or maybe a three weeks from now.
Got it. And then another question is around could you talk in a little more detail about how the time series data is handled in Azure SQL Edge?
So as I was saying earlier, there are two mechanisms which we introduced to handle time series data. The first is what is available through the streaming engine itself. So essentially things like windowed aggregations, your anomaly detection on the incoming stream of data, your filtering of incoming stream of data, the ability to join multiple streams together or multiple time streams together. Right. So those are the capabilities provided by the streaming engine itself. And then once
Mhm.
the data lands in the SQL database, we are working on providing capabilities or optimizations to have specific time series indexes or time bound indexes, which allows better retrieval of time series data. And then finally, the third thing we are working on is introducing support for new T-SQL query constructs. So for example, we introduce support for date bucket function. And similarly, we are looking to introduce support for things like gap filling,
Mhm.
interpolation, and all of those to assist in querying of time series data.
Got it. Our final question is around support. So
Mhm.
the audience wants to know if we will be providing support during public preview and if they want to go into production when you GA the product on those lines.
Yes, so you will, I mean, we will have support available as part of public preview. So essentially, if you have an Azure subscription and you are deploying SQL Edge through Azure IoT Edge, you can use the Azure subscription mechanism or Azure mechanism to open a support ticket with Microsoft CSS and request uh, help with deployments or with troubleshooting specific issues with SQL Edge. If you are looking to deploy SQL Edge in a production environment, then the recommendation would be that you reach out to Microsoft, where we work with you to understand the deployment scenario, to understand the complexity of the scenario, and then we work with you to provide or to support that solution.
Got it. I think with that, we are at the end of Q&A. Sarah, final comments?
Yes, thank you, Sia. So yeah, I mean, Azure SQL Edge is now available in public preview, and over the course of the last 1 year, we have heard or we have talked to multiple customers, and we have learned from them about their IoT requirements, their IoT solutions. And I'm super excited about the next phase of this journey where we can learn about more IoT scenarios or more IoT requirements which Azure SQL Edge can solve. And I just can't wait to see what our customers or what organizations will build with Azure SQL Edge. It's exciting times ahead. With that, I would like to thank everyone for joining us for this session. I hope you guys have had a great Microsoft Build 2020, and I hope you enjoy the rest of the build sessions. It's about 3.5 hours left before build wraps up. So I hope everyone makes the best use of that 3.5 hours time. Thanks, everyone.
Thank you.